your PY Physics Practical course USPHP 06 is mutual inductance, determination of mutual inductance between the primary and secondary coil by using the ballistic galvanometer. That is the aim of our experiment. Now here to determine the mutual inductance between the primary and secondary coil. So you will require the primary coil, secondary coil. This transformer is given and the two terminals of the primary, here these are the two terminals of the primary, they will working as a primary coil terminals and the remaining two will be working as the secondary coil terminals. So here you are having the two coils, primary coil, secondary coils are given. So you have to determine the mutual inductance between them by using this ballistic galvanometer. So this ballistic galvanometer is given. So by using this ballistic galvanometer, you have to determine the M, the mutual inductance between the two coils. Now, once you know the aim of the experiment, then the circuit diagram which is required to perform this experiment, we'll see that first. Now here, in order to perform this experiment, we will require primary, secondary coils, galvanometer, then you will require the tap key, you will require the Rayleigh's key, you will require the cell, you require the resistance box, you require the fractional resistance box, then you require this 4-way key and one 2.2K resistance is required. So like this way, these are the requirements of the circuit. Now circuit diagram as it is given, so using that circuit diagram you will be able to connect the circuit in order to perform this experiment. Now here this 4-way key, 1, 2, 3 and 4, these are the 4 terminals of this key. Now from one number it will go to the resistance of 2.2, then it will go to the galvanometer, another terminal of the galvanometer will go to the secondary, and this secondary circuit will be completed. Secondary coil circuit will be completed. Similarly, there will be another circuit. Now here from this secondary, here it is connected to Rayleigh's key, lower terminal, and upper terminal of the Rayleigh's key is going to the number 2. So from one number 2.2K resistance, from that it will go to the galvanometer, from the galvanometer it will go to the secondary, another terminal of the secondary is connected to the lower terminal of the K2. That is the two keys are there in the Rayleigh's key, K2 and K1. So here this is connected to the K2. Upper terminal of K2 is connected to 2 number. So here these 2 number. So like this way, the circuit of secondary coil is completed. Now for the primary coil circuit, so here these are the primary coil terminals. Now here from the here 3 number, from 3 number you will connect it to the resistance box. Fractional resistance box is connected across 3 and 4. Here you can see across 3 and 4 the fractional resistance box is connected. 3 number will go to the resistance R. R will, another terminal of the R will go to the positive of the cell. Another terminal of the cell, that is negative of the cell, will go to the K1's upper terminal, and lower terminal of K1 will be connected to the primary coil. Another terminal of the primary coil will go to the 4 number. So this way, once you see the circuit diagram, you will be in a position to connect the circuit. Though it looks more connections are here, but step by step, connect the primary circuit, connect the secondary circuit, then you will be in position to complete the circuit connections. Now here you will have to show it to the teachers before starting the experiment. Once you connect the circuit, keep the will start the procedure of the experiment. You have to note down the time period of this galvanometer. Now for this given galvanometer, the time period is 2 seconds. So that we will note down as t equal to 2 seconds. There is no need to measure. Standard time period for this galvanometer is 2 seconds. It is given. Then actual experimental part will start. Now this K1 and K2, these two keys are there. So when I will close K1 first, the cell will be in the circuit of primary. Now the current will flow through the primary circuit, and when K2 will be connected, a EMF will be induced in the secondary. When the current will flow through the primary, the EMF is induced in the secondary, and because of that there will be a throw, a deflection will be produced in the galvanometer. So here as I will press it, initially the deflection will be 0. I will connect the key across 1 and 2. Then when you will connect the key across 1 and 2, the secondary circuit will be completed. Now press the 1, K1, K2. Now here release it, you will get the throw. You will get the throw in the galvanometer. So on one side the first throw will come, on the same side when the spot of the galvanometer will come back, that will be theta 3. So first throw will be theta 1, second throw will be theta 3, and once you know the theta 1 and theta 3, you can find out the corrected throw of theta 0. So the basic concept is that when the current is passing through the primary coil, the EMF is induced in the secondary coil, and because of that there will be a deflection produced in the galvanometer. That you have to note down. Same reading, close K1, K2, then release it. As you release it, make and break this, you will break the circuit, the deflection will be produced in the galvanometer. Alright, so here you can see on one side it is, then once again it will come on the same side. You note down the correct deflection, theta 1, theta 3, find out theta 0. 10 times same readings you have to repeat. Then the second part of the experiment is that close the key 3 and 4, this here. Now in this case primary coil and secondary coil will be in the series. Then the value of the resistance, this resistance which you are having, you keep it 0.1, then 0.2, 0.3, 0.4. Now it just follows the Ohm's law. As the resistance will change, V equals to IR. So as the resistance will change, the throw which is produced, you can see initially. Now for small value, you keep K1 and K2 close. Now the deflection will be produced. Is as I will increase the resistance, this R, small r, the deflection will increase. Now you can see the deflection is more. So here this deflection you will have to note. So from 0.2 R equal to 0.2, R equal to 0.4, 0.6, 0.8 and 1 corresponding deflection phi, steady deflection produced, that is denoted by phi, you have to note down. Then you have to plot the graph of R against the phi. A straight line graph will come, and there is a formula given to determine the mutual inductance between these two coils. You require their periodic time, you require the slope of the graph R upon phi, you require the corrected throw phi, theta 0, substitute the values. You will be in a position to determine the mutual inductance between these two coils. So like this way this experiment is performed. Now when I will explain it by PowerPoint presentation, that time I will show you actually how the readings are there, how the graph is there. Then error calculation, you have to calculate the error. How much is the error produced in the value of M by given formula. So that also I will explain you that time. So this is the experiment of mutual inductance introduced between the, when the current will flow to the primary coil, how much is the mutual inductance between these two coils, that we are determining experimentally. So this is the experiment of group 2 USPSP 06. Stop.